Hello class, welcome back. Well, this tutorial will introduce the unsupervised learning method, Kmeans, and in order to implement this Kmeans clustering method in R, we will use two methods, Kmeans and SimpleKmeans from RWeka. We will also show you some different approaches for cleaning data. To remove the missing values, and also we will try using the original data to create clusters, and also use the cleaner data to create clusters, while in addition we will try to normalize those values and then do the clustering. Well, let's first import our data. This data set is from the social media profiles from teenagers. Those teenagers are from a high school, from freshman year to senior year, and it was collected from 2006 to 2009. And besides collecting those teenagers' age, gender, and so on, they also the most importantly, they extract their SNS, their social media profiles, and extract the keywords from their profiles. While they included 36 different keywords, and count the frequency of these keywords that appears in each one of the teenagers' social media profile. So let's see the structure of this data set. So as I mentioned before, they have the year of the graduate of the teenagers, and also the gender, the age, and friends. Friends variable include the social connection of those teenagers. Well, if they have 5 friends connected to this student, they will have 5 here. The rest 36 variables are the keywords we mentioned. So the value or the frequency of this keyword appear in the teenager's profile. And well, let's check let's first see the distribution of their graduate year. So you can see the grad year is equally distributed, so means each class has includes 7,500 students, and the percentage is 25% for each year. And also let's check the gender. Well, let's look at the original data set for a second. Well, you can see for the gender column, besides F and I, we can see a lot of NA. Well, NA represent the missing values. Well, so if we try to see the distribution, like the percentage of distribution for the gender variable, you can see that if you add the percentage of female and male, the value doesn't equal to 1, which means there are missing values. So we use an additional parameter, use NA equals to if any, to include the frequency of the missing values. So you can see for the gender variable, we have 2,724 students that doesn't have the gender, and the percentage is about 9%. Well, similarly for the age variable, let's check the original data set. Even though we don't have the NA value here, we do have a blank. So, and also let's check the summary let's check the minimum value and maximum value for this age variable. Well, you can see that the minimum minimum value for age is only 3. The maximum is over 100. So because we only collect the data like those students are from the high school, so they should be like the age of them should be larger or equal to 13 and less than 20, and those values are definitely outliers or mistakes, so we want to like treat them as also missing values. So here we use the if-else function to to give NA to the outliers and also the blanks. So we have used if else before, but here this first parameter is the condition. So if the teen age value, like the value of the age, satisfy this condition, which is between like 13 and 20, we will give the original age value to this teen's age. Otherwise, we will give NA to this age value, and we give this value back to this teen's age. Therefore, we replace the original age value with this new age value. So let's see. After we transform the age variable, we can see the minimum value for age variable is now like larger than 13, and the maximum is 20, and the rest of them those like unsatisfied condition will be put in as NAs. So you can see like we increased more than 400, the NAs increased more than 400. So like we put 400 more students as NAs, and well, then we want to remove those students, those teenagers without any age or without any gender. So here we use a subset function. Well, this is the first parameter is the original data set, and the second parameter is the condition that, well, if satisfy this condition, then the rows will be included in this final data. Otherwise, it will be omitted. So here, let's see. This represent all the rows, all the teenagers that don't have this gender variable, don't have this gender value. This represent the teenagers that don't have any age value. So this symbol represent OR. So we combine those rows together. So here we have exclamation mark. Well, this means negative, which means we want to exclude those rows. We only include the teenagers both have gender value and the age value. So let's run this one. And let's see the summary. So you can see now, like, remember we used to have 7,500 teenagers for each year, but now we only have like 5,000, more than 5,000 students for each year. That means we remove a lot of rows from our data sets. Well, next is we also try to look at other outliers using this scatter histogram function. Well, you need to first load this psych library. So you can see the x-axis is represent the frequency of people mention. Let me see. Oh, this one. The x-axis represent the people, like the frequency of people mention word sex, and the y-axis is the frequency of students mention blondie. And you can see there are like two very extreme values, like two outliers, and we can certain that this value has the mentioned more than 100 times of blondie, and this teenager mentioned sex more than 100 times. So we want to remove both of them from our like clean data. Well, we already cleaned that data a little bit, so we want to like remove these two additional teenagers. So here we use the function which. Well, which function means like we only include the rows. See here, these are the rows. Well, we include all the columns, but in terms of rows, we only include those teenagers that mention blondie less than 100 times, and also like those teenagers mention sex less than 100 times. So we can exclude these two outliers from our clean data. And next, we want to examine the correlations between the friends. Remember, like beside those keywords, we also have like the students' age, like their friends' numbers. So we want to like examine the friends variable, the correlation between the friends variable with the rest of the keywords. So as you can see here, the correlations are pretty weak. Most of them are positive correlation besides the sex and drugs. So basically means if the students has more friends, probably he or she will mention less sex words, but the correlation is pretty weak, so it doesn't mean anything. Well, let's see the correlation between age and all these keywords. Well, we can see we also have the very weak correlations between the age and the keywords variables. And most of them are negative variables, which means like if the students getting older, they probably will mention less keywords. Well, next we want to use this Peirce-Pinot function to explore the correlations between the 36 keywords. Well, Peirce-Pinot not only present you with the correlations, but also present you with the histograms and also plot their correlations. But because we have a pretty large data set, I already like run this result, and I will later present to you. Noted here, like for the first comparison, we only include the first 6 keywords. So let's see. It may still take a few seconds to show up, but you can see like we all know that the correlation is between 0, 1 to 1. Like positive value means they have like a positive correlations. A negative value means a negative correlations. Well, you can see here, there's are not like a lot of keywords have strong correlations, but we can see if the here we have 0.12 and here also 0.12. So if this this if they mention more softball, they will probably mention more valuable. Or if they mention more softball, they will probably mention more basketball. And these are the first 6 keywords regarding to the sports. And let's see the second comparison from the word 17 to word 22 columns. And here you can see about there is 0.10 means if they mention sexy more, they will probably mention more hot, the word hot. Well, there's one pretty pretty big correlation, pretty significant correlation, which is between band, and this one is marching. So if they mention band, they will probably mention more marching. And the last demonstration is for the keywords from column 35 to column 40. So here you can also see there's one pretty large correlation, Hollister, and this is Abercrombie. Sorry, I couldn't see it clearly. But also you can see here, if they mention there is a 0.2 like correlation between die and death, and also 0.2 correlation between drunk and drugs. So you can like learn some basic correlations from this Kmeans function, but note that if you have pretty large data set, it probably will take a few seconds to load your image for you. Next, we want to build several explanatory models. Well, we want to build the decision tree model using the gender. If you recall that gender is our categorical variable, and we want to use it as our target variable to build a decision tree model. And see here we use the data from row 2 and also from row 5 to 40, which include the gender column and the rest 36 keywords columns. And you can see also here we have a parameter C, which is controlled for the tree sets because we have a pretty large data set. If you have a less parameter C, you will have you have a simpler tree. So here we set C first equal to 0.05, and let's see the tree model. So see here, we didn't include other like age or grad year or friends variables as target variables. We only include those 36 keywords as target variables. And let's see the tree model. Well, this is a pretty large tree because the size of the tree is 99 and we have 50 leaves. And let's see the performance of this tree. Well, we use these 36 keywords to predict the gender of the teenager. So you can see in terms of female, the precision and recall are both high and F measure is very good. But in terms of gender male, you can see that we have very good precision, but recall is a little bit low. So we have only have like the F measure is only 35.5%. And also, we also want to build a naive-based model using RYCAP package and also use gender as our target variable. And you can see data, we only use 36 keywords as predictors. Well, because those 36 predictors are all numeric, well, when we see this model, we cannot see any conditional probability tables anymore. We can only get the mean and standard deviation and weighted sum and precision for each variable, each predictor. And we also we still use the evaluate classifier function to evaluate the model performance. Recall that the decision tree performs so well in terms of the female class, but not very well in the male class. Let's see the naive Bayesian model. Well, in terms of female class, we have a very good precision, but relatively low recall, which will hurt our RF measure. And in terms of male class, well, the naive Bayesian model performs very well in terms of recall, but the precision is relatively low. So, but we still got a better results in terms of male comparing to, let's see if we got a better, I think we got a better result. Yeah, we got a better result comparing to the decision tree model, but for predicting the female class, well, naive Bayesian doesn't perform well as comparing to the decision tree model. Well, next we want to use the grad year as our target variable to build another decision tree model. And this grad year, if you recall, is another categorical variable of our dataset, and it has 4 classes from 2006 to 2009. And see here, we include the column 1, which is grad year, and the rest variables like predictors are still those keywords. And you can see here we set the parameter c to a very small value, so we want to have a smaller tree. And it will also take a few seconds to build this tree, even though we set the value pretty low, pretty small. And you can see here, this is still a pretty large tree, including 73 tree size and 37 tree leaves. And when we evaluate this model using our cleaned dataset, so let's look at the performance of this decision tree model. We only use this 36 keywords frequency to predict the graduate year of the teenager. It is no longer a binary classification problem. It is a multi-class classification problem because we have 4 classes for our target variable. So the performance, the percentage is relatively lower for this decision tree. And we also try naive Bayes model using grad year as target variable. So let's see the performance. Well, the performance is much worse than the decision tree model, especially for the class level 2007. The recall for 2007 is only 7%. And well, next we want to build a explanatory linear regression model for age and friends. Well, those age and friends are two variables that are numeric. So the age and friends variables are considered as the dependent variable, and the um, 36 the 36 keywords are considered as independent variables to explain the variance for age and friends. So let's first look at the age model. We can see among these 36 keywords, there are a lot of words that actually are significant affected age. But when we look at the R squared and just R squares, we can see like only around 3% of the variance of age has been explained by these 36 variables. And let's look at the friends model. Well, similarly, there are a lot of keywords that are significantly affect the number of friends, but they only explain like 2.5% of the variance for the friends number, which are really low. Well, the purpose of using this social media SNS data is not for building any classification models. We want to use this data set to create clusters. While clusters is unsupervised learning methods, and the most simple clustering algorithm is Kmeans. So basically, the algorithm for Kmeans, first you decide like how many clusters you want. For example, we want 3 clusters, and then the second step is to randomly select 3 centers, and those centers are randomly selected, and then they will calculate the distance between each data points and the centers. For example, we have a data point A and we have center 1, 2, 3. If the distance between data point A and center 1 is less than the distances between data point A and center 2 and center 3, well, we will say, well, this data point A will belongs to cluster 1. So after this step, every data point will have their own cluster. Well, the next step is to do the iteration. Well, they will we currently have 3 clusters with data points. Then among these data points, they will calculate the centers again, like recalculate the center values inside each cluster, and then reassign the labels to each data point. So in the end, when no data point changes clusters, it will stop. So probably when data point A belongs to cluster 1 at the first few steps, it will like convert to cluster 3 in the end. So that always happens. So that basically how this Kmeans work. Well, we will implement this Kmeans using 2 functions, Kmeans in class and also SimpleKmeans from our webcam. And we will demonstrate you how to implement them in detail. So first is to decide the value, like how many clusters you need. We identify them as like the k equals to 4, and then we need to set seed for this Kmeans function. Why? Because remember, the first step is to randomly choose the cluster centers. So we want to have like if you have different class centers each time, you have different cluster results. And if you want to have like the same result every time, you will need set C. So they would like randomly select the centers each time, but the values are consistent. And let's look at this Kmeans function. Well, the first parameter is we only use those keywords, like 36 keywords. So the first parameter is a keywords collection, and the second parameter is the value for the K. So the K-means clustering model, we give it a name, team clustering. So let's run this one, and let's see the size for each cluster. So the biggest cluster is cluster 3. It includes like 17,000, more than 17,000 students, while the smallest one is cluster 1, only have more than 500 students. And if you like check the center for each cluster, so for each cluster, those values are in the center. So these values are in the centers of cluster 1, 2, 3, and 4, and so on. So this model, like team cluster, not only have the size and center parameters. When you check the structure, you can see it has 9 different parameters. So you can see, okay, so the first student in our dataset belongs to cluster 3, and second student belongs to cluster 4, and the center values and between the size and so on. Well, the next step is to combine the cluster IDs with our clean data final dataset. So we will use cbind functions. So this one is the column of cluster indicating clusters for each student, and this is our clean dataset we used before, and we combine this column and our dataset and give it a new name, team W cluster ID. Team with cluster ID means team with cluster ID. And you can see now the first column will be the cluster ID, and you can check the cluster ID for first 25 students, or you can look at the first 25 records. Well, next we want to create subsets based on the cluster number, and well, here we will use a for loop. So first we need to create an empty list. So this list will contain 4 elements in the end after the iterations. Well, for the first element, it will include all the rows, all the students that belongs to cluster 1. And the second element will contain all the students from cluster 2, so on and so forth. So this for loop will iterate for 4 times because it is from 1 to k equals to 4. And we also use the which function. So if satisfy this condition, we will include the rows into the this list element I. So here, if the cluster ID equals to, for example, 1, this row will be included into the cluster list element 1. So let's run this for loop, and now we'll have the So this cluster now have 4 elements. We only, well, here we like double square bracket indicating we only use the students that belongs to cluster 1, which is much less subsets, only more than 500, I think, like if I recall correctly. And we include all these students, we give all these rows to a new name, model input, and we use this more than 500 students belongs to cluster 1 to build another decision tree model, also using gender as our target variable. And let's see. Well, if you can like quickly calculate the cluster 1, like only more than 500 students belongs to cluster 1. And well, when we build this decision tree noted here, the index has changed. Before we have from 5 to 40 because this model, this dataset has additionally cluster ID, so the index has been like moved to 6 to 41, which are still the 36 keywords, and the column 3 is still the gender. So the control value C, parameter C, we give C a 0.05. And because it's a like much smaller data set, we have a very very simple tree. Like they predict all the students here as female. So well, we can know that the evaluation is gonna be good for the female class, but very bad for the male class. Well, next we want to use this we want to use a z-score standardized method to normalize our variables, our predictors. Well, why do we need those normalized functions? Because this Kmeans algorithm require us to calculate the distance between two data points. So if we have two variables in this data point, for example, we have age, which range from 1 to 120, for example. But if we also have another like variable, income, well, income, the range for income probably from 0 to 10,000, 100,000 million. And when we calculate the distance, when we use the income calculate distance, the distance will be much bigger if comparing to use the we calculate the distance using the age variable. So that's why we want to use the normalized function to standardize the variables. So here we try the z-score standardized function. Here is how it works. So basically, x is the original value for this variable. This mu is the average value for this column of variable. The sigma is the standard deviation, so it can transform them into a normal distribution. And here we are already include the function called scale. We use the list apply, like we mentioned the list apply function, I think two tutorial back. So if you have any problem with list apply, you can go back to search this function in our previous tutorials. and we like apply this scale function for all the 36 keywords variables, and um, this new data frame is called interest z. And let's first see the final data summary. You can see, okay, for example, the drunk function, the minimum is 0, the maximum is 8. But for after we normalize it, the drunk, the maximum is 19 and the minimum is negative 0.2247. And then we apply the Kmeans function on this normalized dataset. Well, let's see if they have changed the size. Well, the size of the cluster definitely changed, but there is also a cluster that include most of the data points. Sorry. And also you can check the center and also the structure of this clustering model. Well, next we will use this SimpleKmeans function from RWCA. Well, it is a little different than the Kmeans function we used before. First of all, well, this one is the same. Like the first parameter is the 36 keywords, but the second one is the WCA control parameter. It includes the first one, like they have a lot of different options and parameter choices you can look at. Here, N is to identify how many clusters you need. Here we have K, means we still want 4 clusters. V equals to true because we want them to present as the standard deviation. And let's run this one. And when we look at this model, we can see those are the centers for each cluster. Well, they also have they have the initial values here and number of iterations here, and also the sum within cluster sum of squared errors, and also the number, like how many data points fall into each cluster, and the rest of them are the data points. So the second row are the standard deviations we want to include. And next, we want to generate cluster subsets based on the SimpleKmeans clustering. Similarly, we first combine this cluster ID with our final data, our cleaned data. And then you can see now we have the first cluster first column representing the cluster ID. Noted that the Kmeans function, the cluster number is from 1 to 4. For the SimpleKmeans from RWCA, we have the cluster ID from 0 to 3. And also we use a for loop to create a list with each element containing the students belongs to each cluster. So then we will use let's see what's the biggest one. So the biggest one, like the biggest cluster is cluster 3. So we will create a subset only with the students from cluster 3. And we use this subset to create a decision tree. And well, you can see that here the C is still equals to 0.05. Well, we all use J48. You can also try C5.0 decision trees. And let's see the size. Well, because this data set is pretty large, so the size of the tree is large too. It is 89. And when we evaluate this decision tree, we can see well, in terms of female class, it still performs pretty well, but in terms of male, the precision is still high, but the recall is still a problem. And well, next we will use a normalized dataset to create those 4 clusters. And we will see the size for each cluster. Well, if you recall, the size of the, let's compare. Well, if you compare those those 4 clusters with normalized data and the unnormalized data, the size of the clusters are not changed. Well, for the rest our codes, we play with this SimpleKmeans function a little bit by changing the parameter values. For example, here we still use the k equals to k, v equals to true, but we include additional parameter initial equals to 1, while the default initial value is 0, which is randomly select the cluster center. But here the initial value equals to 1 means we will choose the cluster centers using Kmeans method. And let's see. And for this model building, we use this normalized data. And well, I can share you with a website. It includes all the options like parameters for n, initial, c, and so on. And we include it here in the comment section. Well, let's look at the summary. Well, when we instead of randomly select the initial cluster center, we use the Kmeans method, and the cluster definitely changed. And well, there's we don't have an approach to a classification method. You can evaluate your prediction, but clustering is an unsupervised learning method, so you have no values to compare with. So we only can try different cluster methods, but we do not have which one is the best cluster methods, because we do not have evaluations. And we can also here The default distance calculation is using the Euclidean distance function, but here you can change a equals to ycar.core dot Manhattan distance, so change another approach to calculate the distance. And well, when you calculate the distance differently, you will also result in different cluster arrangements. And well, we want to apply the simple Kmeans to both categorical and numeric variables. If you recall before, those normalized data and also the data frame we used before are only include those 36 keywords, but here we want to include every columns, every variables, including the grad year and gender. So when you apply simple Kmeans will pre-process the data for you. It will transform those categorical variables to dummy variables, to either binaries or um, other types of numeric variables. And so let's see. Well, definitely the different cluster will also change. Well, by including the grad year, we have grad year and gender. We have this more equally distributed clusters. So basically, each clusters now the number of data points do not have that much differences now. And the last one is we apply the categorical and numeric variables and also with missing values. While the simple Kmeans, when they receive the missing value, they will treat missing value and give the giving value to this missing cell, and the value is basically equals to the means or median of this variable. So let's see if we have missing values. What clustering arrangements do we have? So by giving those missing values the mean and median value of the variable, we have now exact equally distribute clustering setting. Each cluster includes 7,500 students. So that's basically what we will cover in this tutorial. Thank you for listening. Bye.